Hi everybody, my name's Brasher, and this will be my presentation on evaluating and predicting cost and price index of single-family housing in the U.S. This is for CM 7206, IT for Construction at LSU. If we look here, the project overview is going to be an analysis and a forecast of the data sets provided by the U.S. Census Bureau titled Quarterly Single-Family Houses Sold. The goal of the study is to compare price indexes, actual sales, and typical prices at both national and regional levels. Description of the data sets. We had 4 sheets within the data set provided. Price index is the first one. It's going to be a combined data set where it has annual price indexes and quarterly price indexes for at the national level, and it has only annual price indexes at the regional level. Then the next 3 sheets are really similar. They all pretty much have the same information, just for different categories. It's going to be constant prices, which will have the year, the price index, period percent change, and this will be for actual sales and for typical prices. And then the first one will be constant prices US, so that's the national one. Northeast Midwest will be the regional for Northeast Midwest, and then South and West will be regional for South and West data sets. An objective, it's mostly to evaluate the national and regional data sets. Following successful evaluation, we then want to forecast actual sales and typical prices through 2025 and through 2030. We're going to use clustering to create visual charts for actual sales and typical prices at both national and regional levels. We're going to use correlation to look at the significance of the relationship between regions. Regression, we're going to analyze for actual sales and typical prices at the national level separately. This is going to evaluate the fit of the model and establish or reject the null hypothesis. Forecasting, we're going to forecast from 1963 to 2007 into 2025, and then pending accuracy with the 2025 number, we're going to forecast into 2030. Cluster forecasting is a combination of clustering and forecasting. It's just going to be a visual representation of the forecasting through 2030. Validity, we did have data type constraints for year. It fosters a date format. We also have numeric data for price and price index in relation to the year within the respective row. Foreign key constraints, we do have national and regional data, which separates later in the sheets. Accuracy, we did satisfy accuracy. We satisfied completeness, satisfied consistency, and satisfied uniformity. For pre-processing, we did all the standard stuff: get rid of extra spaces, remove duplicates, parse data, spell check, outliers. So to get into the processes, we start with clustering. As you can see here, we have 5 cluster charts. Each of these is going to be based off of actual sales and typical prices. That's what these 2 trend lines are for different regions. One being the one on the left being the national, and these being regional. This really just gives us a good view of what the data actually looks like. For correlation, we took all the regions' price indexes and ran through correlation. The strongest relationship is the South and Midwest regions at 99.7. The weakest one's going to be Northeast and West at 9.78. They all have a significant relationship, though. In regression, actual sales and typical prices, both very similar results. Shows that there is multiple R shows significant correlation. R square shows the model fits significantly. Adjusted R takes complexity and says it still fits. And significant F is well below 5%, indicating that we cannot reject the hypothesis. For forecasting, we took the historical 1963-2007 data and for national and regional. And using the forecast function, we pushed it through 2025. This includes price and price index at national and regional levels. And then to check our 2025 number, which we got 409,300 for our outside. I've searched what kind single family houses in the U.S., and this is the average number that I got. This is the typical price for 2025, and this is the actual sale for 2025. So our outside number fits really well into this bracket. So then we can push through 2030 since we validated that, which we've already done here on the right. The next thing we're going to do is comprehensive clustering. First, it's going to be to basically graph our forecasted data. As you can see, each region kind of has its own color. So for Northeast, it fosters blue. The light blue will be the typical price. The dark blue will be the average sale, but both of which are for Northeast. That just kind of gives a visual aid. Okay, so final analysis, outcomes, benefits. For isolated clustering, we were successful in providing visual representation. The Midwest and South regions look to be most similar. Northeast and West regions show more variance towards the end. Correlation, successful. We were successful in comparison. South and Midwest regions show the strongest relationship. Weakest relationship is Northeast and West regions. Both of these are supported by the isolated clustering as well. For regression, both average and both actual sales and typical prices both support the hypothesis and the fit of the model to the data. Forecasting, we were successful in predicting into 2025. Then we did pinned accuracy, so we forecasted in 2030, and then we put that into our cluster forecast. I'll go back and look at that real quick. It's pretty neat. So in conclusion, I think it's a great tool for consumers that are looking to move geographical regions, maybe. It's also just potential forecast data onto actual sales and typical prices for the U.S., which could be used in a variety of contexts. Lessons learned, you can make this very complicated if you wanted to. It's really easy. It's important to fully comprehend the nature of the data. There's a lot of rabbit holes you could go down that don't prove fruitful in the end. And you got to know which ones to go down in order to get successful outputs. Limitations in the cluster forecast, the comprehensive one, you can see an initial drop off at where the historical data meets the forecasted data, and I think that's the predicted Y catching up to, or the forecast is making up for the actual Y being variant and moving it more towards the adjusted Y, is what I believe it is. We also omitted period-to-period percent change. That's because we didn't use it in the final conclusion. All right, I think that's it. I hope you guys enjoyed it. Please let me know what you think. Thank you.